Lesson 5-6, Solving Equations. And in this lesson, you learn to solve equations with the rational numbers. It's important to solve equations with rational numbers because when you determine patterns and changes in the weather, you are able to use this particular skill. Okay, let's take a look at this example in meteorology. Hurricanes can be devastating to life and property. The graph at the right compares the statistics for the five most costly hurricanes to strike the U.S. mainland. The two most costly hurricanes were Andrew and Hugo. Together, the damage they caused totaled 38.96 billion. How much did Hurricane Andrew cost? So this was taken when Katrina did not happen. If you remember Hurricane Katrina, if I'm not mistaken, that's the most costly hurricane to date. Okay. So let's just take a look at this example and let's see how to solve this example. Okay, so to find the cost of Hurricane Andrew, we create a let statement just like any word problem. Let C represent its cost. Okay, and we want to write an equation. So in our equation, we know that the cost of Andrew is C, and we need to add, okay, the cost of Hugo, which is 8.49, will be equal to, okay, the total cost, which is 38.96, okay, 38.96 billion for that matter. Okay, so to be able to solve this, we have C plus 8.49 equals 38.96, and just like any equation, one-step equation, we want to isolate C to the left side of the equation. So we need to undo 8.49. If we undo 8.49, that means we need to subtract 8.49 to both sides of our equation. And subtracting it to both sides of our equation, we end up with C equals 30.47. Okay, so when we subtract 8.49 from 38.96, end up with 30.47. Okay, and Hurricane Andrew's cost is $30.47 billion. Okay, so you can solve rational equations such as like that using the same skills you used in for that particular problem. Okay, and we can also solve that using, okay, our involving integers. Okay, so basically rational number equations can be solved using the same skills we used in solving equations involving integers as well. So if we have b plus 3/5 equals 3 over 2, okay, so we want to isolate b on the left side of the equation. That means we need to undo 3/5. So let's copy the problem. We need to undo 3/5, and in order to undo 3/5, we need to subtract 3/5 to both sides of our equation. Okay, so subtracting 3/5 to both sides of our equation, we now have b equals, because this is 0, 15 over 10 minus 6 over 10, because the LCD of 2 and 5 is 10, and we rename 3 halves with the LCD of 10 to become 15 over 10, and we rename 3/5 with an LCD of 10 to become 6 over 10, and b equals 9 over 10, because now you have like fractions. You simply subtract 6 from 15 and keep the denominator. Okay, and if we want to check our answer, we simply substitute the value of b, which is 9 over 10, to our original equation. So this becomes 9 over 10 plus 3/5. Is it equal to 3 halves? Again, we look for the LCD, which is 10. We rename 3/5 with the LCD of 10, which becomes 6 over 10. And if you notice, 9 plus 6, it will give you 15 over 10, or 3 halves. So the solution is 9 over 10. Let's take a look at another example. Another example, we are going to deal with decimals. A minus 3.2 equals 2.7. We want to isolate A. That means we need to undo 3.2. And in order to undo 3.2, let's copy the problem first. We add 3.2 to both sides of our equation. And adding 3.2 to both sides, we end up with A equals 5.9. Then checking our answer, we simply substitute 5.9 to A. And there you have it. Our answer checks out. So the solution is 5.9. Okay? And let's take a look at the last example. Example number 2. Okay, meteorologists use barometers to measure air pressure in the atmosphere. This is a real-world application of our skill. Changes in pressure indicate that there will be a change in the weather. As a hurricane approaches, the barometric pressure at 7 p.m. is 28.65 inches. Okay, talking about inches of mercury right here. It had dropped 0.37 inches from the previous reading at noon. What was the noon reading? Okay, so when when there's bad weather, when a low pressure area approaches where you are. So a low pressure area always indicates bad weather, and a high pressure area always indicate good weather. Okay, FYI. So let's create a let statement. Let P represent the barometric pressure at noon because that's what it's asking. Okay, that's where we get our let statement from. So we create an equation. The pressure at noon is P. We know that. And then it dropped, meaning we need to subtract. Okay, 0.37 inches. Okay, is simply 0.37 will be equal to 28.65. So we now have an equation P minus 0.37 minus 28.65, and we need to isolate P. That means we need to undo negative 3.7, and in order to undo negative 3.7, we add 3.37 to both sides. So adding 0.37 to both sides, we've isolated P on the left side, and 28.65 plus 0.37 will give us 29.02. So the barometric reading at noon was 29.02 inches of mercury. Okay? And that's the end of our lesson. Thank you for watching.